Why is the double-slit experiment said to be the most terrifying physics experiment in the world? In the 17th century, Dutch scientist Huygens first proposed the wave theory of light. He believed that light propagates like water waves. When two beams of light meet, interference creates bright and dark stripes. However, Newton's particle theory dominated the 18th century thanks to his authority. Until 1807, British physicist Thomas Young successfully proved the wave theory through the double-slit experiment. He let a beam of light pass through two slits in a barrier. If light were particles, two distinct bright stripes should appear on the screen. If light were a wave, zebra-striped interference fringes would appear. The experimental result was exactly as Young predicted. The appearance of interference fringes declared the victory of the wave theory and shattered people's previous understanding of light. In the early 20th century, the rise of quantum mechanics revealed the strange nature of the double-slit experiment. Scientists upgraded the experiment to a single photon emission mode. Only one photon was emitted each time. Theoretically, the photon can only pass through one of the slits and cannot interfere with other photons. Therefore, two bright stripes should appear. However, the results were unexpected. As the number of photons accumulated, interference fringes appeared again on the screen. Who was the single photon interfering with? This question puzzled physicists deeply. To solve the mystery, scientists installed detectors before the slits, trying to observe the photon's path. But an even stranger phenomenon occurred. When the detector was on, the interference fringes disappeared from the screen. Only two bright stripes remained. When the detector was off, the fringes miraculously reappeared. The photon seemed to have consciousness, able to sense whether it was being observed, and switching between wave and particle forms accordingly. This discovery completely shocked the scientific community. The act of observation itself actually changed the experiment's outcome. The behavior of microscopic particles no longer exists independently of the observer. To explain this phenomenon, Einstein proposed the concept of light quanta. He believed that light has dual characteristics, being both a particle and a wave. Its form depends on the act of observation. The Copenhagen interp of Cum further stated that before observation occurs, microscopic particles are in a quantum superposition state, being neither purely a wave nor purely a particle. Only when observed does the wave function collapse and the particle presents a definite form. This theory sparked fierce debates between Einstein and Bohr. Einstein firmly believed that God does not play dice, and that the physical world should follow deterministic laws. Bohr, on the other hand, insisted on quantum mechanics randomness and the decisive role of observation. To further explore the mysteries of the quantum world, scientists designed the delayed choice experiment. They moved the detectors behind the slits and decided whether to observe. Only after the photon had passed through the slits, the results were once again shocking. No matter when the detector was turned on, as long as observation occurred, the interference fringes would disappear. If not, they would reappear. This implies that future observations seemed to influence past events. Causality of time is no longer absolute in the quantum world. This phenomenon, which defies classical physics, has forced scientists to rethink space-time and the nature of observation. The quantum eraser experiment took this strangeness even further. Using quantum entanglement techniques, scientists erased the path information after photons passed through the slits. Surprisingly, interference fringes reappeared. This shows that not only observation affects the result, but the presence or absence of information also determines particle behavior. The bizarre nature of the quantum world seems to completely transcend human cognition. As Bohr said, before observation occurs, no physical quantity exists objectively. This cognitive upheaval has sparked philosophical reflections on the nature of reality. The world we observe, does it truly exist independently of the observer? Are scientific theories merely human descriptions of nature, rather than ultimate truths?